Hello, Algebra 1 students, and welcome back to your Semester 2 final review. Today we're looking at problem 34, which comes from lesson 7.2 if you want to look back and refresh your memory. We're discussing the domain and range of a graph, in particular the domain and range of a parabola. We'll cover the domain first. A reminder, the domain, at its core, measures what numbers you're allowed to substitute in for x in this equation. So our equation y equals negative x squared minus 1. So it seems like I could plug 1 in here if I wanted and do some math. I could plug in negative 7. I could replace x with 0. I could replace x with a million, with 1/2, with pi, anything we wanted. There's no restriction on what I can substitute in for x. And so that means if I wanted to list all of the x's that I'm allowed to use in this equation, well, it would be every number out there, which is why our domain is always all real numbers. Okay, that means D is out. That's not a domain of all real numbers. That means you're only allowed to use x's between negative 1 and 1. So we're done there. All the rest have the correct domain. Okay, now we get to the range. But before we get to the range, we should talk about a different way that you can see the domain. Because the domain is all real numbers, it means that every number on the x-axis has to match up to our graph. So for example, 0 on the x-axis matches up here. 1 from the x, 2, 3 kind of matches up, but don't forget that parabolas get infinitely wide. You can't always see it right away, but they do. And so we can see that 4 from the x-axis will match up, and 5 will match up, and the negatives will match, and so on and so forth. All of the x's, if you start on the x-axis and draw down, in this case to the graph, match up to a spot on the graph. So we can also say that the x's are discussing how wide the graph gets. The x-axis goes wide. And because our parabolas get infinitely wide, that means that our x is all real numbers. So let's look at the domain, or let's look at the range, and we can see this in a few different ways. Our range is technically the list of y's that we can get as an answer to our equation. So you could sit there and plug in every x you want, like 0, 1, 100, a million, negative a million, so on and so forth, and write out a list of all the y values that you get. But that sounds pretty tedious. So instead of doing that, it's very easy visually to see what the range is, because the range is what are the y's on the graph. Well, if you look up here, we're going to start on the y-axis. A y of 5 never occurs on my parabola, right? There's never a point on here that has a y value of 5, because that would have to be way up above the x-axis. And so we know that 5 is not part of our range, nor is 4, nor 3, nor 2, nor 1, nor 0. Oh, but wait. Once we get to this spot, once we get to negative 1, there is a spot on my graph that has a y of negative 1. And negative 2 actually happens twice. Negative 3, negative 4. And looks like every number starting at negative 1 and below it will occur on my graph. Which is why sometimes you hear the range described as how tall your graph gets. And the highest my graph ever gets is negative 1. The lowest my graph ever gets, well, because of these arrows, it goes infinitely low, so we say negative infinity here. And so that is actually our range. We could say that the range, the y values, start at negative 1, and they can be equal to negative 1 because there is a point at negative 1, right? So we can be equal to negative 1. But then we are also below negative 1. So we can say that y is less than negative 1. Now, the way that we write that together is we say that y is less than or equal to negative 1. And so we should have our answer over here, which looks like C. If you wanted to write this in our fancy interval notation, you could also say that the lowest my graph gets is negative infinity with a parenthesis, because we can't be equal to that, and the highest it gets up here is negative 1 with a bracket, because we can be equal. But you should expect to see this notation for the most part on your Algebra 1 final. This is more Algebra 2. So thanks for tuning in. Hopefully that was a decent explanation of domain and range, or width and height of the graph. And feel free to keep tuning back in if you need more help for that Algebra 1 Semester 2 final exam.